Okay, guys, here is another question from a past paper, and we are on Euclidean geometry. If you do not know where to get these past papers, just on your Android cell phone, Play Store, and just check out JSD Solutions. That's an app that for each grade there is an app, so you will get the past papers for different subjects. Of course, here our focus is mathematics, and these videos are actually in relation to past papers that are posted in there. So you can see there is a link there. You will find some of the links, of course, in those apps that link you to the YouTube channel. Okay, so we are trying to say here, if you do not understand the solutions in the app, go for the link, and then it will take you to the YouTube video, and then you'll be able to get an explanation of what is going on there. We are hoping that you benefit from this and you really find them useful. So that's question 10 in this case. And then we are told again in the diagram, O is the center, here is O of the circle, A of the circle, okay, full stop. You see there's a full stop. Then A, B, C are points on the circumference of the circle, okay. Chords AC and BD, where is AC? There's AC and BD, and radii AO and BO, okay, and CO are drawn. So actually, they have been very kind enough to tell you that, hey, watch out, you've got radii there. And they are saying, basically, you've got isosceles triangles. So we can see where this is going by looking at the diagram. Angle at the center is twice angle at the circumference. And remember, this one of the mandatory proofs that you have to know, okay? And guess what? It has come in a different fashion in this question. It has come as an exercise, not they are not saying construct or anything. The construction is already done for you. Okay, so yes, the size of O1 in terms of x. So this thing here is x, okay, and this thing here is y. It was told angle A is x and angle B is y. So that we were given, and we have see, it is already there also in the diagram. So there was no need, there wasn't much trouble. Now, because of the radar, I know C1 is x, and I know that C2 is y. So that's an information that I can put in because I know I've got isosceles triangles. So therefore, O1, okay? So if you remember back in grade 8, when you started learning this math or geometry story, you had that. And if you had that angle and this angle there, then you knew that this angle here is that plus that. So we're going to use this same old concept right here. So O1 is actually C1 plus A, which is x plus x. And guess what? That thing is 2x, okay? Hence, prove the theorem that states the angle subtended by an arc at the center, which arc in this case is arc AB, is equal to twice the angle subtended by the same arc at the circumference. Which other angle is being subtended here? It is actually angle C. So this thing here is twice that thing there. So we, in effect, now they are giving us a required to prove statement. So I'll write RTP, and my required to prove statement is that AOB is 2ACB. That's it. So what I'm going to do here, I'm going to use, as I said, the same strategy I used in 10.1 to prove this, and that you can see why it is 3 marks. Okay, so I have what is AOB? Or AOB is essentially O1 plus O2. Okay, and I must show basically that this thing is what? C1 plus C2. That's it. Aim. This is my aim basically, to achieve that thing. So I know O1 already, that's taken care of. So I can just quickly find O2. So O2 is C2 plus B. And we know C2 is Y, we know B is Y. So this thing is 2Y. And what is your reason here? Exterior angle, okay, of a triangle is is equal to the opposite interior angle. Okay, I'm sure you know the short conventions to use for these things. All right, and by the way, that was the same reason down here for 10.1.1. Okay, so finally, we can see now, so therefore, O1 plus O2 is actually equal to a 2x plus 2y. We showed in AO in here, previous question, that O1 is 2x, and then we just showed that O2 is 2y. So this is just 2 into x plus y. But this x plus y is just C1 plus C2, okay? And this is 2, if you like, C, okay? Angle C1, angle C2. You'll pardon me here. This thing was supposed to be 2 here. I left out that. But of course, in the required to prove statement, it has some sense in it, okay? So that's it, guys. That is how easy Euclidean geometry is. What makes it maybe difficult is the complicated diagrams and all that. But believe you me, when I say this thing is easy and actually fun, okay? Like any other game, as long as you know the rules of the game, you will have fun playing the game and you will want to go to the next level. It's essentially the same thing with mathematics, with subjects, topics of mathematics, your geometry, your calculus, and so forth. So just familiarize yourself with the theorems, know the converses as well, because that's what you are required to use at times, okay? I hope you've enjoyed this. Cheers.